Welcome to the class on fluid visionary. Today we will be discussing one more problem in connection with the reaction turbine. That is, we will be discussing radial flow reaction turbines. In today's class, we will be discussing one problem in connection with the Francis turbine. So here is our problem. The following data is given for a Francis turbine. The net head H is equal to 60 meter. Speed of the turbine 700 rpm. Shaft power 294 kilowatt. Overall efficiency 84%. Hydraulic efficiency 93%. Flow ratio 0.2. Breadth ratio, that is, breadth ratio means depth to breadth ratio, okay, that is equal to 0.1. Outer diameter of the run is equal to 2 times inner diameter, that is d1 is equal to 2 times d2. And Francis turbine means it's an inward flow reaction turbine. So from the name itself you have to conclude that it's a inward flow reaction turbine. So the outer diameter means it will be d1 and the inner diameter will be d2. So it is given outer diameter equal to 2 times the inner diameter. So d1 is equal to 2 times d2. Okay. The thickness of the vane occupy 5% of the circumferential area of the runner. So we have to write the equation of a Q as 0.95 into pi d1 b1 vf1. That is 5% is taken by the thickness of the blade, so we will get only 95% of the total flow. So we will be multiplying the equation of Q with 0.95. Q is equal to 0.95 pi d1 b1 vf1. The velocity of flow is constant at the inlet and outlet. The velocity of flow is constant at the inlet and outlet, that is vf1 is equal to vf2. And the discharge is radial. Discharge radial means we can conclude that beta is equal to 90 degree and v omega 2 is equal to 0. So not v omega 2, vw2. Okay. Determine the gauge blade angle. Gauge blade angle means we will specify gauge blade as alpha and beta, that are called the gauge blade angle. And it is mentioned in the question that beta is equal to 90 degree. Okay, so we will write, we have to calculate the value of alpha. That is the first thing we have to calculate, the gauge blade angle. The second thing we have to calculate the runner vane angle at the inlet, that is theta and phi. The third thing, diameter of the runner at the inlet and outlet, d1 and d2. The last one, width of the wheel at the inlet, b1. Okay, so we'll draw the velocity triangle as it is given. Beta is velocity is radial at the outlet. We can write beta is equal to 90 degree. We will draw the velocity triangle as this, as our inlet velocity triangle will v1 vr1 vf1. Outlet velocity triangle will have vr2 and vf2 is equal to v2 and u2. We don't have any vw2 component in the outlet velocity triangle. Okay, and this is our given data. And the first thing we are going to calculate the gauge blade angle alpha. So alpha can be written as tan alpha is equal to vf1 divided by vw1 minus u1, or vf1 divided by v1. vf1 is given in the question. vf1 is equal to vf2. So we have to find the value of vf1 by using the equation flow ratio. Flow ratio is the ratio between vf1 by root 2 gh. By using that equation, we can calculate the value of vf1. So we got the value of vf1. So our aim is to calculate the value of alpha. For obtaining the alpha, tan alpha is equal to vf1 divided by vw1 minus u1. So next thing we have to calculate the u1 and vw1. So vw and u1 can be calculated from the equation hydraulic efficiency, overall hydraulic efficiency. Okay, so overall hydraulic efficiency, we can calculate the value of vw1. So we need u1 for that. So u1 can be calculated by pi d1 and by 60. So from that we can calculate the value of u1. So hydraulic efficiency is equal to vw1 u1 divided by gh. H is given in the question, g is known value, hydraulic efficiency it is given in the question. So from that we will get the value of vw1. Okay, next, so we got the value of vw1 and u1. So the next equation we will be using is the discharge equation. Q is equal to 0.95 by d1 b1 vf1. As it is mentioned that 5% of the discharge is blocked by the circumferential area, we will be using the equation 0.95, and we will be using the equation of Q for calculating the value of diameter. Okay, the value of Q can be obtained by the from the equation water power is equal to rho g QH divided by 1000. So water power can be obtained from the equation overall efficiency shaft power by water power. Overall efficiency is given in the question. Shaft power also given in the question. From there calculate the water power. From water power we can calculate the value of Q. From Q we can calculate the value of diameter. Okay. So first we will calculate the value of from the overall efficiency we will calculate the value of water power. We will calculate the value of water power. Water power is equated with the rho g QH equation. From there we will get the value of Q. So the value of Q is obtained. This is the water power equation. This is the value of Q. By comparing this, you will obtain the value of diameter. Okay. Here we are substituting B1 as a 0.1 D1. In the question it is given that breadth to depth ratio is equal to 0.1. Breadth to depth ratio is equal to 0.1. That is, in the breadth equation we will be substituting for B1 we will be substituting 0.1 D1. Okay, the value of VF2 is known, so we will substitute all the value, or the only one unknown is D1. We will get the value of D1. Okay, so next thing we will be calculating the U1, and using the hydraulic efficiency equation we will calculate the value of VW1, and using U1 and VW1 we will calculating the equation for the angle alpha. Tan alpha is equal to Vf1 by Vw1. We will get the value of alpha as 13.93 degree. The next thing we will be calculating the vane angle theta and phi. Tan theta is equal to Vf1 by Vw1 minus U1. So we will get the value of theta. And next thing is the phi, Vf2 by U2. So U2 can be calculated as by d2n by 60. The value of d2 can be calculated from the equation d2 is equal to d1 divided by 2. So we will get the value of U2. From that you can calculate the value of phi. So we'll get the value of 5 as 37.74 degree. The last thing we have to calculate the value of D1 and D2. Already we will write the value. And the last one is the breadth of the wheel. So since B1 by D1 is given, we can calculate the value of B1 as 0.1 times the D1. So it will be 54 mm. So we have calculated all the values. So our calculations are over. Thank you.